Hello again. In this video, we're going to talk about how we find the derivative of a composition of three functions using the chain rule. Okay, so let's say you have this function here and you want to find the derivative of it with respect to x. So in other words, you want to find dy dx. Well, the first thing you should notice is if you're going to find the derivative of this function, you're going to have to use the chain rule because this is a composition of functions. And anytime you take the derivative of a composition of functions, you need to use the chain rule. And remember, there's two different forms of the chain rule that you can use. They both give you the same answer, so it doesn't really matter which one. But in this case, I'm going to use this form of the chain rule, the one that says dy dx is equal to dy du times du dx. Now remember, this assumes that y is written in terms of u and u is written in terms of x. And so that's where we should start. Okay, so what we're going to do is we're going to let u be the inner function in this composition. So in this case, the inner function would be this one, e raised to the cosine of x. So I'm going to let that be u. Okay, then the outer function would be just sine of u, because this is equal to u. Okay, now we have y written in terms of u, and u is written in terms of x, which, if you remember, is the condition that you have to satisfy in order to use this form of the chain rule. Okay, so now let's apply the chain rule. So now we need, so dy dx is the same as dy du times du dx. Well, what's dy du? Well, it's the derivative of this with respect to u. And the derivative of sine of u with respect to u is cosine of u. Okay, so that's our outer derivative. And then du dx, that's our inner derivative. That's the derivative of this with respect to x. And I'm just going to write it as du dx for now. And then we're going to find this on the side. And once we find it, we'll plug it back in. So now we have to find du dx. Now to find du dx, we actually have to find the derivative of this function with respect to x. But notice that this is a composition of two functions as well. And so we're going to have to use the chain rule to find the derivative of this function. Okay, so why don't we do this? Let's say the inner function, in this case, we're going to call it v. Now you have to pull another variable out of the air. I do not want to use y, u, or x because I've already used those. So I'm just going to use another variable, a different one from the ones we used before, and I'm going to call the inner function for this composition v. Now normally you would call it u, but we've already done that when we did this the first time. So for this particular composition, I'm going to call the inner function for it something different. I'm going to call it v. Okay, if we do that, then that would mean u is equal to e raised to the v power, and that's our outer function for this composition. Okay, so this is the inner function, and this is the outer function for this composition. Notice when you plug v into here, you do get e raised to the cosine of x. Okay, so now we want the derivative of u with respect to x, and notice you can't do that directly because u is written in terms of v now. But you can still do it using the chain rule. So what you have to do is you have to find the derivative of u with respect to v, since u is written in terms of v, and then you have to multiply that by the derivative of v with respect to x, which v is written in terms of x. So we can find that derivative. Notice that one way of checking this is the dv's on one on top and the one on the bottom. You can think of those as sort of canceling out. and that leaves you with du over dx. Just like the du's cancel here, leaving you with dy over dx. Okay, so let's find each of these derivatives. All right, what's du dv? Well, that's the derivative of this with respect to v, and the derivative of e to the v with respect to v is just e to the v. Okay, so that's our outer derivative. And then the inner derivative would be the derivative of this function with respect to x. So the derivative of cosine of x with respect to x. Well, the derivative of cosine is minus sine. So this gives us minus sine of x. Okay, and then let's go ahead and replace the v. Remember, v is equal to cosine of x, so this is really e raised to the cosine of x. And then I'm going to put this minus sign in front. It doesn't matter, it's multiplication, so I can, it's really a minus 1. I can multiply in any order that I want, so I can multiply by negative 1 first. Okay, and then that's getting multiplied by sine of x. Okay, so now we know du dx. But remember, du dx is just this part from the first time we used the chain rule, right? The du dx here is the inner function the first time we used the chain rule. So let's go back up here and plug in for du dx this. And then that gets multiplied by the cosine of u, which was the outer function the first time we used the chain rule. Let's go ahead and replace the u. Remember, u is equal to e raised to the cosine of x. So this is going to be cosine of this. Okay, and then let's just kind of clean this up a little bit. Again, you can take this minus 1 and you can put it in front. And that's all you can do to clean this up. Notice you cannot multiply the e cosine of x and the e cosine of x here because this e cosine of x is inside the cosine function. So you cannot combine both of these. This one's not inside the cosine function. This one is. So they can't be combined. Okay, so that's the final answer. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.